Okay, for what we have in section 3.1 in ALEKS, okay, we have functions f of x and g of x in parts A and B, and it says to determine the compositions where we're looking at f of g of x and g of f of x, and whether f and g turn out to be inverses of each other. And for what we have in number 1a, okay, we have functions f of x and g of x, and both of these are set equal to 6 over x, whereupon x does not equal to 0. And for the compositions, now taking f of g of x and g of f of x, okay, we have, first of all, okay, we have with f of g of x, all right, so you have g of x is equal to 6 over x, and like what we did with compositions, okay, we're filling in for the input function, which had to be a g of x, okay, so you have 6 over x, and again we're going to operate in accordance with f of x is equal to 6 over x, so you have f of the input is equal to 6 over the input. Now instead of x, I have the input to be 6 over x. So in terms of following through, we're going to have not 6 over x, but 6 all over 6 over x. And dividing by a fraction will be the same as multiplying by the fraction's reciprocal. So you have 6 times x over 6, and so that will be equal to x. And for what we have in the case of g of f of x, now we have the input function to be f of x. Again, so we have 6 over x, and in terms of what we have in the follow through, okay, we have operating in accordance with g of the input equal to 6 over the input. We're going to have now with the input at 6 over x, you have the same bit of history to repeat, so you have 6 all over 6 over x. And this turns out to be the same problem all over again. So you have is equal to x, and so since the compositions both end up being at x, it's going to follow that f and g are inverses of each other in part A. In the crossover to what we have for part B, okay, we now have f of x is equal to x plus 4, and for g of x, okay, we have equal to negative x plus 4. And looking at what we have with the compositions, okay, so we have f of g of x. Again, we have g of x, we have at negative x plus 4. And in accordance with operating along the lines of f of the input equal to the input plus 4, we're going to have with the input at negative x plus 4. So you're going to have, in place of x, can we have negative x plus 4? And we have plus 4 once again. And what's going to happen in this particular case is that in following through, we're going to have constants to combine, and the output we're going to have at negative x plus 8. And for g of f of x, okay, so we have f of x as the input, so we have g of x plus 4. And taking what we have now, operating in accordance with g of the input equal to the negative of the input plus 4, it will turn out that we're going to have the negative of the quantity of x plus 4 plus 4, and this will translate out to negative x minus 4 plus 4 negative 4 and 4 will cancel out, and this will come out equal to negative x. And since we have both compositions to be other than x, now for this particular set, f and g are not inverses. So in going back and taking what we have now, so we had from part A, okay, so we had f of g of x is equal to x, g of f of x is equal to x, and these are inverses of each other. In part B, okay, whenever we had f of g of x, okay, this came out to negative x plus 8. For g composed of f of x, we had the negative of x, and we had the f and g are not inverses of each other. And in checking, the result is correct. Okay, for what we have in problem number 3, okay, we have the corresponding one-to-one functions g and h, which are defined as follows. Now, a one-to-one function is going to be a function whose inverse is also going to be a function. And now we have for the function g, we have the ordered pairs as follows. Okay, so we have negative 9, 6, negative 8, 7, 6, 9, and 9, negative 9. And if I were to express what I have for the inverse, what was y will become x and vice versa. So in the rewrite, we're going to have the ordered pairs in the inverse at 6, negative 9, 7, negative 8, 9, 6, and negative 9, 9. Now, for the first part, okay, in the inverse, whenever we have x equal to 9, it's going to follow that for the value of the inverse function, this will be the y value whenever x is equal to 9. Okay, so you're looking at the y value whenever the x input is at 9, and we have in correspondence, okay, this is going to end up being at 6. Now, for what we have in the second part, we're looking at h of x equal to 6x plus 13. And it says to find out, okay, what the expression will be for the inverse. So we have h of x. Now this is going to be a functional notation for what we otherwise say is going to be y. So to say that h of x is equal to 6x plus 13, it's going to be the same as saying y is equal to 6x plus 13 in the x and y coordinate system. Now in looking for the inverse, I'm going to interchange the x and the y. So we're going to have, in this statement, we're going to have that x is equal to 6y plus 13. And I'm going to solve this equation in terms of y. And this y is going to be in reference to the inverse of h of x. So in isolating y, I can take 13 away from both sides. So I have x minus 13 is equal to 6y. And we have with division by 6, I have x minus 13 over 6 is going to be equal to y. So we have that y is equal to x minus 13 over 6. And again, this expression in y is going to make reference to the inverse of h of x. So you have the inverse of h of x. This will come out to x minus 13 all over 6. Now, in looking at what we have for a function and its inverse, okay, so for h composed with the inverse at 1, and since we have h to be a one-to-one function, again, composition between a one-to-one function and its inverse at x is always equal to x. So it's going to follow that whenever x is equal to 1. Okay, so this will come out to 1. All right, so just taking what we have, typing in. So we have in this particular case, all right, so we got for, okay, now the inverse function of g at 9, okay, that was equal to 6. Okay, now we have with inverse function of g of x, whenever x is set to -9, it's going to follow that we have for the corresponding y value. Okay, that is going to end up at 9. Okay, so I misread the first part of the problem. I read the input as being 9 as opposed to -9. Okay, but again, so we have for the output, okay, that is going to be at 9. And we have for the inverse of h of x, okay, so we're going to have at x minus 13. And taking that expression, okay, we have dividing by 6. And for the composition between h and its inverse, and composition between a one-to-one function and its inverse will compose as the output, where the output is the same as the input, and we have to come out to 1. So we have upon checking, and the result is correct. Okay, for number 4, we have a given function f of x is equal to the square root of 5 minus x, followed by the addition of 8. And the domain we had to be the set of values x less than or equal to 5. And we have this laid out in interval notation. And it says to find the inverse function and its domain. All right, so we have with the given function f of x, we have equal to the square root of 5 minus x, followed by the addition of 8. And again, f of x, this is a functional notation for what we otherwise say is going to be y. So here y is equal to the square root of 5 minus x, followed by the addition of 8. And looking for the inverse. Okay, so we're going to interchange the x and the y. And just taking what we have in the rewrite. So we have x is equal to the square root of 5 minus y, followed by the addition of 8. And what I'm going to do is that I'm going to isolate y ultimately. So if I take 8 away from both sides, so we have the x minus 8 is equal to the square root of 5 minus y. And now we're going to free up the y expression from the radical. So we're going to square both sides. And we have, upon squaring, okay, so we have the square of x minus 8 is equal to 5 minus y. And getting the y term, which we have at the moment to be negative y, I'm going to take 5 away from both sides. And right now, I'm going to have the square of x minus 8 minus 5 is equal to negative y. And if I change the signs at both ends, whether it's through multiplying or dividing by -1, okay, what is positive becomes negative and vice versa. And so it's going to follow that we have that y is going to be equal to 5 minus the quantity of x minus 8 raised to the second, and this y is going to make reference to the inverse function. So you have the inverse function is equal to 5 minus the square of x minus 8. Okay, now in looking at comparing what we have for f of x equal to the square root of 5 minus x plus 8 so I have y equal to the inverse function of x, and that was equal to 5 minus the square of x plus 8. Okay, and wait, that 5 minus the square of x minus 8. I'll just mention, okay, so we had so you have for the domain of this function, that was set of values of x less than 5. Okay, so we have, like, whenever x is 5, the corresponding y value is at 8. Let's say we have 4. 5 minus 4 is going to be 1, and we have 1 plus 8 is 9. And let's say if we have x at 1, 5 minus 1 is 4, square root of 4 is 2, plus 8 is going to be 10. And for what we have in this particular case, all right, so we have so you have for y is equal to f of x, okay, is equal to square root of 5 minus x plus 8. They're going to have among your order pairs. So you have 5, 8, 4, 9, 1, 10. And I could actually continue if I had, like, let's say, if I had like -4, I have like -4, 11. And now for the order pairs, the inverse, I would have 8, 5, 9, 4, 10, 1, 11, -4. Okay, and so for the domain of the inverse, you'll be looking at set of values of x greater than or equal to 8. So going from 8 inclusive on out to infinity. Okay, so just looking at what we have in this particular regard. Okay, so we have for this one case, you have 5 minus to the second. Okay, and we have for the domain, okay, so we have so going from 8 inclusive, and we have going out to infinity, and checking the result, and it is correct. All right, for number 5, okay, we have the given one-to-one function f defined below, whereupon we have f of x is equal to the cube of the quantity of x plus 7. And it says to find out what the inverse of that function is going to be. All right, so we have in this one, okay, if we look for the inverse, again, f of x, functional notation for what we say is going to be y. And here we had that y is equal to the cube of x plus 7. And if we interchange the x and the y and solve for y, where this newfound y is going to be the inverse function of f of x. Okay, so we have interchanging x and y. So we'll have in the rewrite, okay, we have that x is equal to the cube of the quantity of y plus 7. And going from y plus 7 to the third to just y plus 7, I'm going to take the cubic root of both sides. So we have the cubic root of x is equal to y plus 7. And if we isolate the y, so I'm going to take 7 away from both sides. So the cubic root of x minus 7 is equal to y. So you have y is equal to the cubic root of x minus 7. And that y, again, is going to reference the inverse function of f of x. So I have is equal to the cubic root of x minus 7. And so just taking what we have now. So the cubic root of x, and again, we don't want the negative 7 inside the radical, and checking the result, and that is also correct.